For graph of motion, this chapter, we are learning about how particles move around and giving different types of graph that we can actually draw. So from here, we have the first graph that we are going to talk about is actually called the distance versus the time graph, where on your y-axis, you have the distance. And on your x-axis, it is your time. And for distance, usually we can measure in kilometer or meter. Time, usually we can use hour or minute to calculate. So let's look at the first graph here. This is the first graph. So you can see that this graph actually slanted towards your right side. If you look at this blue line here, when we calculate the gradient, okay, so it will actually give us the speed. So as a rule of thumb, for distance versus time, when you calculate the gradient, it will give rise to the speed. So how do we calculate gradient? Is that we use two coordinates, which is y2 minus y1, divided by x2 minus x1. So when you calculate this gradient, it will be the speed of the vehicles or speed of the particles. So for this blue line here, when you calculate the gradient, it will give rise to a positive gradient. It will give rise to a positive gradient. Okay, next we move on to the second graph here. On my right, you can see that this graph has a horizontal line of particles. So what does this tell you? It gives you a zero gradient. So therefore, it has a zero gradient, which means that it has the velocity or speed of equals to zero. That means the particle is not moving. Particle is not moving at all. That's why you have the horizontal line. Okay, next we move on to the third graph here on your bottom. So this is actually a graph slanted towards your left. Okay, let's make this an orange color. So it will give you the negative gradient here. That means this particle is moving at the backward direction. Moving backward direction. That's why you will have the negative gradient. So there are three scenarios where the particles can be reflected on the graph. One is the positive gradient, which is slanted towards your right side. Horizontal, which means that it has a zero gradient. And lastly, a negative gradient, which slants towards your left side. Okay, now we move on to the first example. Ahmad cycles from his school to a shop to buy some stuff. After that, he cycles back home, and the following graph shows the journey of Ahmad. So first part of the graph here, from 150, from 150 until 270 here, that means the particle or Ahmad is actually moving, cycling from his school to a shop. Okay, and after that, he stays at the shop for some period of time. That's why it has a constant velocity here. So it's a zero speed. And after that, he cycles back home. And that's when you get the T. So the following graph shows the journey of Ahmad from school to the shop, and after that from shop back to home. So question number 1, given that the time taken for Ahmad to return home from the shop is 20 minutes. So find the value of T. So we know that when he is cycling from this point here, from the orange point here, until this part here, he's actually cycling back home. Okay, so the time requires for this period is actually 20 minutes. So what is the value of time t according to this graph? What you can do is you can use 30 plus 20, you get t value of 50. So the answer will be t equals to 30 plus 20 equals to 50 minutes. That's the answer for question number 1. Now we move on to question number 2. Calculate the speed of Ahmad when he cycles from his school to the shop in meter per minute. Okay, so meter per minute, it basically means that it is the speed. Okay, so when you think of speed, it is the gradient here. So this part will be the speed that you need to measure. Okay, from the blue for this blue part here. Okay, so from 150 here up to 270, so this will be the gradient that you need to find out. Gradient of the graph or speed is equivalent to your y2 minus y1 over x2 minus x1. So what is your coordinate for this point? Okay, so what is actually the coordinate of this point? So this coordinate of this point is 15, 270. The coordinate of this point here is 0, 150. So next we can find out what is the gradient. So we use y2 minus y1 over x2 minus x1. Okay, it's better that I put a bracket here so that we need to minus first, then only we divide. Okay. So what is your answer for this part? So 270 minus 150 is 120 divided by 15. The answer will be 8 meters per minute. So we know that Ahmad actually travels at the speed of 8 meters per minute from this part until this part, which is from the shop to the from the school to the shop. Okay, the last question here, calculate the average speed of Ahmad for the whole journey in meter per minute. So average speed means you have total distance divided by your total time. So what is the distance that has Ahmad traveled? So Ahmad has traveled from 150 points until 270. So you take the difference between these two values. So you get 120 meter plus the distance from the shop back to his home, which is 270. 270 meter. You need to add them all up together, divided by the total time, which is 50 minutes, which is the value of t, 50 minutes. So the answer will be 390 divided by 50. Your answer will be 7.8 meter per minute. That's your final answer. If you think that this calculation is complicated, you may pause and then you can try to understand and do your own calculations. So next we move on to another questions here. Anna drives from her house to the market. So this part here will be the house. And this part will be the market. And then she continues to drive to her workplace. And finally, he reaches the destination of her workplace. So the following distance time graph shows the journey of Anna based on the graph given. So let's try to find out what's the answer. The first question, calculate the driving speed of Anna from her house to the market in kilometer per hour. So when you see it is the speed, that means it is the gradient that you need to find out from this part here, from the house to the market. So what is the gradient here? You need to find out the two coordinates, which is 20 and 30. Can you see that? So this part here, the coordinate is 20, 30. Yeah? Sorry about that. All right. So at the house here, it is 0, 0. 0, 0 is the coordinate. So using these two coordinates, and we can therefore find the gradient or the speed. So y2 minus y1 over x2 minus x1. So it is always better for me to write down the bracket in order for us to do the calculation on the subtraction first. So 30 minus 20, you get 10 divided by 20, and therefore the answer is 0.5 kilometer per hour. This will be the final answer for question number 1. So next we move on to question number 2. Calculate the duration of time when Anna's car stops at the market. So when Anna's car stops at the market, it's actually between 20 to 65, because that's when the graph actually has the horizontal or zero gradient here. So what you need to do is you just take 65 minus 20. Duration of time when Anna's car stops. So you get 65 minus 20, and therefore you get 45 minutes. Okay, the last one, given that the driving speed of Anna from the market to her workplace is 60 kilometers per hour, find the value of S. Okay, so where is the market here now? So the market now here is actually this point to the workplace. And this market here, you need to use the new coordinate, which is 65 and 30. Okay, so that will be this coordinate, this part here. And when it travels until it reaches the workplace, what's the coordinate of this workplace? So the coordinate will be 95S. Okay. So using these two coordinates, therefore we can solve the questions on finding the S value. Okay. So speed is equal to S minus 30 S minus 30 over or divide by 95 minus 65. Okay. But the thing is that because the speed 60 has a unit of kilometer per hour, and therefore we need to further divide this 95 minus 65 by 60 to get hour. And can you see that from this x-axis graph here, it has a value or it has a unit of minute. So we need to change this minute to hour. So this value, we need to further divide it by 60 again. All right, so the speed now is 60. Okay? So you can move this whole thing here to your left side. Okay, so you get something like 95 minus 65 in brackets equal to S minus 30. And this you need to divide by 60 here. So essentially, I move everything in blue, okay, towards here, multiply up. So the next step is that 60 and 60, they have cancelled off each other. So you only have 30 here equals S minus 30. 30 plus 30 equals to S. So therefore, S will equal to 60. So now we got the final answer of S equals to 60 here. That's the end of my presentation. Thank you.